May, June 2022, paper 1, variant 3. Question 1. A lump of modeling clay is moved from a small measuring cylinder to a large measuring cylinder that has twice the diameter. The reading on the small cylinder goes down by 20 centimeters. By how much does the reading on the large cylinder go up? Okay, by how much does the reading on the large cylinder go up? If the small cylinder goes down by 20, okay, then the large cylinder also has to go up by 20 centimeters cubed. Yes, it's the same volume. Again, we're talking about the same volume of the lump of clay. This lump of clay has a volume of 20 centimeters cubed. When you remove it from the small cylinder, the volume will decrease, the water volume will decrease by 20. When you add it to the large cylinder, the volume, okay, the water volume, it will be displaced by 20 centimeters cubed. Does the diameter have to do with anything? No, it doesn't have to do with anything at all. Okay, it only has to do, okay, what we actually care about is the volume of the modeling clay. When we remove it, the volume will decrease by 20. When we add it again, the volume will increase by 20. And that's it. Okay, so it has to be 20 centimeters cubed. Yeah, question 2. The graph shows the motion of a car. Which row correctly describes this motion? What's happening to the acceleration? And can I calculate the distance traveled? Can I calculate the distance traveled? Yes, I can calculate the distance traveled. How? Using the area. Yes, the area under the graph. Area under the graph. What's happening to the acceleration? The acceleration, is it constant or is it increasing at a constant rate? Again, I'm not asking about the speed. Okay, he is not asking about the speed, he's asking about the acceleration. The acceleration in this case is constant. The speed is increasing at a constant rate. Yes, the speed is increasing at a constant rate. So if he had written speed, you could have chosen C or D. But since he wrote acceleration, you cannot say that the acceleration is increasing. No, the speed is increasing. The acceleration in this case is constant. Why is the acceleration constant? Because we have a constant slope. The acceleration is constant because we have a constant slope. What is the distance traveled? How can I calculate the distance traveled? The area under the graph. This is a graph of a trapezium. This is a trapezium. How can I find the area of the trapezium? Base 1 plus base 2 over 2 times the height. And the height would be the distance between them. This is the height. Base 1 is 5 plus base 2, 15. Divide by 2 times the height, which is 20. 10 times 20 is 200. Okay. Any problems? Okay. This is a very easy question. A man stands next to a track. A train traveling at 40 meters per second takes 2 seconds to pass the man. What is the length of the train? How can I find the length? How can I find the length of this train? Yes, distance equals speed times time. Okay, distance equals speed times time. Question 2 is A. Question 3, distance equals speed times time. The speed was 40 and the time was 2, which is 80 meters. Yep. Okay. Yep. 4 students are given 2 different objects, P and Q. P and Q. Each student measures the mass of P and the weight of Q. Okay. The results are shown in the table. Which row gives a possible result? The mass of P and the weight of Q. Which result do you think could be correct? Which result do you think could be correct? Yeah, I need some answers. Can I choose, for example, A? A would be wrong. Okay. Okay, why? Because the weight has to be in newtons. Okay, B, kilograms, yes, and weight would be in newtons. This is correct. So B is the actual answer. Okay, this is the actual answer. Okay, so it is B. You have a problem with A, with question two again. يا شباب, in this case, the speed is increasing. Okay, in the table, he's asking about the acceleration. He's not asking about the speed. In the table, he's asking about the acceleration. The acceleration is not increasing. The acceleration is constant. The speed is increasing. Okay, this, yes, if he was asking about the speed, he would have said the speed is increasing. But this question, he's asking about the acceleration. And the acceleration is constant. Why is the acceleration constant? Because it is a constant slope. It's a straight line, a constant gradient. Okay? It's constant. It's not increasing. The gradient is not curving. Whenever he asks about the acceleration, you need to check the slope. You need to check the slope. If he's asking about the speed has increased. Initially, the speed was 5 meters per second, and finally, the speed was 15 meters per second. Yes, the speed has definitely increased. Okay. Question five. We have some liquid, which was initially 30 centimeters cubed. Some more liquid was added until it reached 50 centimeter cubed. The reading on the balance increases by 30 grams. What's the density? Density equals mass over volume. Density equals mass over volume. What's the mass and what's the volume in this case? Yeah, what's the mass? The mass hmm, increased by, yes, the mass increased by 30 grams. Mass increased by 30 grams. What about the volume? Hmm. What's the volume? Can I choose, for example, 50? Or can I choose 30? Hmm. The volume should be what? The volume has to be the difference between them. Yes, the volume has to be 20, exactly. The volume has to be the difference between them. 50 minus 30. 50 minus 30. Why? Because initially the volume was 30 and finally the volume was 50, so the difference between them is 20 centimeters cubed. The mass, the difference in the mass, for example, initially the mass was 70 and finally the mass was 100. Okay, so the mass has increased by 30. That's why we chose 30. Okay, so density equals mass over volume. 30 divided by 30 divided by 20 is 1.5 grams per centimeter cubed. Hmm, Yeah. Any questions? Shall please, if you have any questions, just say so. Okay, don't wait until I skip like two, three, four questions and then I have to come back to this question. If you have any question, just say so immediately. Mm. Yeah, question six. We solved this question before. We have a force 6 newtons, which is facing downwards at point X. If you have another force, which is 4 newtons, if you have another force, which is 4 newtons, you need this force to balance this beam. You need to use this force in order to balance this beam. It would be obvious, it would be quite uh, logically, you should use the 4 Newton force where on the beam, okay, and it should be facing upwards. Okay, it should be facing upwards. That's quite logical. If you have another force, if you have one of the forces facing downwards, it would be logical to have the other force facing upwards, especially if the pivot is on the left-hand side. If the pivot is on the left-hand side, then one of the forces should be downwards and the other force should be upwards. Okay, now, if the force is smaller, this is 4 newtons, which is smaller than 6 newtons. If the force is smaller, what should you do? What should you do with this force? Should it be closer to the pivot or should it be further away from the pivot? Okay, if the force is smaller and you need to balance the beam, should the force be closer to the pivot or should the force be further away from the pivot? Hmm. Moment equals force times distance. Force times perpendicular distance. Okay, so if you have a smaller force, you need a larger distance. Yes, it has to be further away. If you have a smaller force, you need a longer distance. So the 4 newtons should be facing upwards and should have a distance which is longer than, okay, 40 centimeters. It should be vertically upwards. Okay, so we'll cancel out B, A and B. And it should be 20 centimeters to the left or to the right of X. So it's quite apparent that it should be to the right of X. And that's it. Okay, that's it for this question. Okay, if you have a small force, you need to increase the distance. If, for example, the force was 8 newtons instead of 4, if the force was 8 newtons, it should have been to the left of x. 8 newtons should have been to the left of x. Why? Because it's a larger force. If you have a larger force, then you should decrease the distance. Okay? Hmm. Okay. Yeah. Any questions? Shabab, any questions? Okay. Which bars are in equilibrium? Hmm. Which of these bars is in equilibrium? Are they both in equilibrium? None of them? Both of them? Hmm. Which bars are in equilibrium? Ah, question, previous question was D. Okay, was to the right of X. Hmm. Question 7. Yep. Which bar is in equilibrium? Hmm. Bar 1 is in equilibrium. Yes, bar 1 is in equilibrium. Why? Because the upward forces are equal to the downward forces, and this bar will not rotate. Okay, it will not rotate. Is bar 2 in equilibrium? Hmm. Is bar 2 in equilibrium? Let's take, for example, the pivot to be in the middle. For example, if the pivot was in the center of this bar, what would happen to this bar? It would rotate. No, it would rotate. طيب, okay, Mr. Anna, I won't put the pivot in the center. I'll put the pivot on this side. Again, it will still rotate due to this force. Okay, if you put the pivot on this side, it will rotate due to this force. So this pivot, this bar, will not be in equilibrium. It will never be in equilibrium. This bar, yes, the forces are equal. I know the upward force is equal to the downward force, but the moments are not equal. Okay, the resultant moment is not equal to zero. So only bar one only is in equilibrium for this question. Okay, yeah. Any questions? Yeah. 7B. 8. 4 objects have different base areas and the centers of masses are in different positions. Which object? Which object is the most stable? Which object is the most stable? Huh. What should you do to the area? Yes, we should increase the area. We should increase the area. What should we do to the center of mass? The center of mass has to be low. Yes, that's quite easy. Okay, increase the area and the center of mass has to be lower. In which form is energy stored by stretching a spring? When you stretch a spring, huh? What form of energy is this? Stretching a spring. Hmm. Yes, elastic. Excellent. Elastic potential energy. Good. Hmm. What is meant by the what is meant by the power of an engine? Hmm. What's meant by the power of an engine? Ah, power is the energy per unit time. Yes, this is correct. The energy per unit time. Okay. Hmm. A force of 14 newtons is applied to the head of a nail, causes a pressure of 25 newtons per millimeter squared. What is the cross-section area of the tip of the nail? Huh. We have the force, we have the pressure. How can I find the area? Hmm. Yalla, pressure equals force over area. If you need the area, equals force over pressure. Force is 14 divided by the pressure, which is 24. It would be A. Yep. Any questions? On what does the pressure at X depend? Yep. On what does the pressure at X depend? X is the point below the water. Okay, at what does the pressure at X depend? The depth of the water at X. Yes, definitely the depth of the water at X. Yes, A. Not the length of the. We don't care about the length. We don't care about the surface area or the thickness of the dam. Okay, we only care about the depth of the water. Okay, above X. Hmm. The properties of two states of matter are listed. State 1 and state 2. State 1, molecules move quickly and randomly. There's a large distance between the molecules. State 2, molecules vibrate about a fixed position. They're closely packed. Definitely. Yes, this is quite easy. One is gas and two is a solid. Yes, they vibrate about a fixed position. The first one moves randomly and quickly and they have large distances. Quite easy. Hmm. Yeah. Question 14. A gas in a container is cooled, but the volume of the gas does not change. Gas in container is cooled, but the volume does not change. What happens to the pressure and what happens to the kinetic energy? Hmm. When the yep. When the gas cools, what happens to the kinetic energy? It decreases. Okay. And then what happens to the pressure? When the kinetic energy decreases, they move slower and they hit the walls slower and weaker. Yes. With less force, which would be A. Yes, this is correct. Hmm. حلو. Question 15. The iron cylinder of an engine is to be fitted into a piece of aluminum. The outside diameter M, okay, of the iron cylinder is slightly larger than the diameter of N. Okay. What is the best action to fit the cylinder into the aluminum? This cylinder M is slightly larger than N. How can we fit it inside? N, cool the aluminum and cool the iron? No. We actually need to heat up the aluminum. Yes, heat the aluminum and cool the iron. Yes. You need to expand this and you need to contract this so that they could fit into each other. It would be C. Yes. Okay. حلو. A solid in a closed container is heated until it completely melts. A solid is heated until it completely melts. Which diagram shows the shape and the volume of the solid before and after heating? This is an excellent question. It was a solid. Initially, it was a solid. And then it completely melted. How will it look like before and after? Hmm. Before melting and after melting. Yes. A lot of you are saying D, which is correct. Yes, D. Um, this would be a gas. This would be a gas, which is wrong. Okay. It's, it's not a gas. Before and after that, this would be freezing, which is wrong again. Okay. It was a solid, became a liquid. Hmm. What's the name of the effect by which the water forms? How does the water form? How does the water form? Yes, condensation. Condensation. يلا. Any questions? يلا حلو. In which situation is the main transfer of thermal energy by convection? يلا. By convection. Hmm. By convection. Which of these is by convection? Hmm. Okay. Hmm. Okay. So I have a lot of answers. A lot of you are saying A, B, okay, and C. Okay, let's check them out. A, food cooked under a grill. Under a grill. This is the heat, صح? This is the heat source. The grill is the heat source. If I have some hot air, for example, if I have some hot air, this is some hot air. Will the hot air move downwards? Can the hot air move downwards? No, cannot move downwards. Why? Because we know that when heated, the hot air, the density of the hot air decreases and so it rises upwards. Okay, so this would be wrong. The food in this case would be heated by infrared radiation, not by convection. The food in this case would be heated by radiation, by infrared radiation. So A is wrong. B, a cold drink stored in a vacuum flask. Okay, transfer from the air to the drink. From the air to the drink, it cannot travel, it cannot be transferred by convection. Why? Because you have a vacuum. Again, inside the vacuum, the only heat transfer, the only process would be by infrared radiation. So this would be wrong because you have a vacuum. Okay. Food cooled in a freezer. In a freezer, you have the freezing compartment. Okay, the freezing compartment, which gives off cold air. What happens to the cold air? Cold air, what happens? It's more dense, so it moves downwards, and the hot air moves upwards. So this is convection. Yes, this is convection. Okay, this is convection. In any any cooling element, for example, the air conditioning unit, you always have the air conditioning unit where it's always near the ceiling. You always put the cold units above. Okay. Yes, it would be C. Question 19. Yeah. Metal container has the shape of a hollow cube. Which side is the best emitter? Yeah. Best emitter. Ah, best emitter. It should be dull black. Yes, definitely dull black. Best emitter. Yeah. Which row is correct? The amplitude and the wavelength. What's the amplitude and what is the wavelength of this wave? Ah, quite easy. The amplitude is 1 and the wavelength is 8. 1 and 8. B. Yes, correct. Yes. A girl is sitting on a rock in the sea looking at the passing waves. She notices that 5 complete waves pass in 20 seconds. What's the frequency? How can I calculate the frequency? We know that the frequency is the number of waves per unit time. Yeah, number of waves divided by the time. Number of waves is 5 divided by time is 20. 5 divided by 20 is 0.25. Yes, that is correct. A ray of light passes from air through a sheet of glass and out the other side, as shown. Which two angles are equal to each other? This is a really interesting question. I need someone to solve it correctly. Okay, this is a really nice question. Can someone solve it correctly? Which two angles are equal to each other? Hmm. Okay, okay, I have a lot of nice answers. This is the normal on this side, and this is the normal on the other side. Hmm. Okay, someone's saying A. A is actually wrong. Okay, A is wrong. Why is A wrong? The angle of incidence at boundary 1 and the angle of incidence at boundary 2. The angle of incidence at boundary 1 is this angle, which is I. Is it equal to the angle of incidence at boundary 2, which is this I? No, they are not equal. Okay, angle of incidence at boundary 1 and angle of incidence at boundary 2 are not equal. They're not equal. Okay. Someone is saying D, angle of refraction at boundary 1 and angle of refraction at boundary 2. Again, angle of refraction at boundary 1 would be this small angle R, and angle of refraction at boundary 2 would be this small angle R, which would be wrong. Okay. Yes, I know the right answer. Okay. A lot of you are saying C. Yes, C is correct. Yes, C is the correct answer. The angle of incidence at boundary 1 and the angle of refraction at boundary 2, they are both equal. Yes, thank you for everyone who has said the correct answer. Okay. Angle of incidence at boundary 1 and angle of refraction at boundary 2. Yes, that is correct. Ha. حلو. Again, you need me to explain it again. Okay, angle of incidence هنا I. Angle of incidence is I. When it enters the glass, what happens to the angle of refraction? It decreases. The angle decreases. When it exits, when it goes back to air, what happens to the angle? It increases again. Okay, when it exits, it increases again. For example, initially the angle was 50. When it's inside the glass, it becomes 30, and then when it exits, it becomes 50 again. So that's why the angle of incidence at boundary 1 is equal to the angle of refraction at boundary 2. Okay? Okay. In which labeled position should the object be placed to produce a real image? Okay, that is smaller. Again, smaller. To produce a small image, what should we do to produce a small image? What should we do to the object? Hmm. Yes, A, definitely. Whenever you increase the distance, okay, whenever you put the object very far away, whenever you put the object very far away, the image decreases. Okay, the image gets smaller. Which statement correctly compares radio waves and X-rays? Radio waves and X-rays. Okay. Radio waves have a longer wavelength and the same speed in vacuum. This is correct. Yes, thank you. The speed of sound in air is 340 meters per second. Student 1 and student 2 stand 170 centimeters apart, as shown. Student 1 fires a starting pistol. Student 2 hears the sound twice. Okay, he hears the sound twice. Once by the direct route, okay, and once by the reflection from the wall. So he will hear the sound 2 times. What is the interval between hearing the 2 sounds? What's the interval between hearing the 2 sounds? So you actually need to calculate, okay? Listen up. You actually need to calculate the time 2 times. You need to calculate the time 2 times. Why? Because he will hear 2 bangs. He will hear 2 bangs. The first bang, okay, would be directly from student 1 to student 2. The second bang, okay, let me draw it using a different color, okay, would be by reflection from the wall. It will go hit the wall and then reflect back to student 2. Type. Let's calculate the first time. Let's calculate the first time. Okay, the initial time would be very simply speed equals distance over time. So time equals speed over distance over speed. Okay, time equals distance over speed. This is the initial one, which is in blue. Okay, this is the initial time. Distance over speed, which would be 170 divided by 340. The time would be zero point 0.5 seconds. Okay, this is the initial time. The first bang, you will hear the first bang after zero point 0.5 seconds. Okay, let's calculate the time taken for the second bang. For the second bang, this was an echo, so speed equals 2 distance over time. If I need to calculate the time, 2 distance over speed. Okay, 2 distance over speed, which should be 2 times 170 divided by the speed, which is 340. So the second time would be 1.0 seconds, or 1 second. 1 second. What's the difference? What is the difference, the interval between hearing the first sound and the second sound? The difference between them would be 1 minus zero point 0.5, which is 0.5 seconds. Okay, that's the question. Okay, he doesn't want the timing for the first bang or the timing for the second bang or whatever. No, he needs the difference between the first bang and the second bang. That's it. Okay, so you need to calculate it 2 times. Okay. Hmm. Any questions? Any questions, يا شباب? Okay. 26. Can I multiply the speed by 2? No, you cannot multiply the speed by 2. No. Never, never multiply the speed by 2. Um, يلا, you only multiply the distance by 2. ماشي. Question 26. A student attempts to make a permanent magnet. This is cancelled. Okay, permanent magnets. How to make permanent magnets has been removed from the syllabus. Question 26 is cancelled. Question 27. Object X and object. Okay, so you have an object and you have two magnets, Y and Z. Okay, a student places object X on a balance. The student first brings magnet Y and then Z. Okay, as you can see, the initial reading was 49.3, and then 48.7, and then 48.1. 49.3, 48.7, and 48.1. Both magnets, okay, one magnet has south pole facing object X, and the other magnet has the north pole facing object X. Which statement explains the results? Why is the second or the third result, less than the second result? Why is 48.1 less than 48.7? Magnet Z is stronger. Yes, magnet Z is definitely stronger. So magnet Y is weaker. Yes, magnet Y is weaker because it decreased. Yes, okay, because it pulled it. Yes, because there was a force of attraction. There was a stronger force of attraction. Okay, this is excellent. So yes, magnet Y is weaker. Magnet Y is weaker. So is it B or D? So I'll cancel out A and C. Is it B or D? Object X, is it a permanent magnet or is it an iron block? Is it a permanent magnet or is it a an iron block? Okay. Hmm. Any ideas? Yes. It has to be B. It cannot be D. Why is D wrong? Why is D wrong? Because it cannot be attracted in both cases if it was a permanent magnet. If it was a permanent magnet, it would have been attracted in one case and the other one, it would have been repelled because you have South Pole and North Pole. Okay. You have South Pole and North Pole. Okay. Uh, wh- okay. Again, if you have the South Pole and you have the North Pole, okay, and both of them are attracted. Both of them attract object X. Then this object X has to be an iron block. Why? Because it is a temporary magnet. Okay, it's a temporary magnet. Okay, so it has to be B. Again, Shabab 26 has been cancelled because you're not required to know how to create a permanent magnet. Okay. Um, don't get the difference between a permanent and a temporary magnet. If it was a permanent magnet, if it was a permanent magnet, it would have had, for example, north and south poles. So in this case, it would have been attracted, which would have been correct. But if it had north and south pole, the reading wouldn't have decreased. Actually, the reading would have increased. It would have been, for example, 51.1. مثلا. Okay, it would have increased. Why? Because it's now being repelled. It's now being pushed downwards. Okay. That's if it was a permanent magnet. Okay. A girl rubs a plastic rod with a cloth. The plastic rod then repels a positively charged object. The rod repels a positively charged object. The rod now has to become a. If it repels a positively charged, it has to be positively charged. So, how can an object become positively charged? Can it gain any protons? No, it can never gain any protons. It has to lose electrons. Okay, it has to lose electrons. Hmm. يلا. 29. Which circuit shows a meter being used correctly? Hmm. Which circuit? Hmm. Definitely, yes, A. What about to measure the current. Yes, definitely it is A. Okay, yeah. A resistor and the battery are connected. Okay, again, I said 25. We said 25 is B. Okay. Uh, Question 30. A resistor and the battery are connected in series. The value of the resistor is 20 ohms. The potential difference is 4 ohms, 4 volts. What's the current in the resistor? How can I calculate the current? I equals hmm, V over R. Yes, I equals V over R. What's the V? The voltage is 4 and the resistance is 20. So the current would be 0.20 amperes. Okay, it's very simple. I equals V over R. Hmm, Okay. Which other components does the circuit contain? It has a cell. What other components are inside the circuit? We have a switch, a variable resistor, and a heater. Okay. A switch, a variable resistor, and a heater. Hmm. Yep. What's the combined resistance between X and Y? This is quite easy. What's the combined resistance between them? Hmm. Any ideas? Combined resistance between X and Y. Definitely has to be less than 4. Yes. Definitely has to be less than 4. Okay. Hmm. Question 33. Don't get why. 32? Why is it less than 4? Because whenever you have resistors in parallel, the total resistance, the combined resistance decreases. Whenever you have resistors in parallel, the combined resistance decreases less than the least resistor. So, for example, if you had 10 and 5, then the combined resistance would be less than 5. Okay. Combined resistance has to decrease less than the least resistor. That's it. Okay. You are not required to actually calculate the combined resistance in a parallel circuit. Which statement about the identical lamps in a parallel circuit is not correct? Identical lamps in a parallel circuit. If one lamp blows, the others remain switched on. Okay, again, we're looking for the incorrect statement. This is correct. The current in each lamp is different. They are identical lamps. They're identical lamps. So the current should be the same. The current should be the same. Okay, let's check the other statements. The lamps can be switched on and off separately. Yes, this is correct. The lamps have the same voltage. Yes, because they are in parallel. So the only incorrect statement would be B. Okay, each lamp has the same current. Why? Because they are identical lamps. Okay, they are identical lamps. Okay, okay. Why is a fuse used in an electrical circuit? Why do we use fuses in electrical circuits? Hmm. No, it's not D. It's not to save electrical energy. Fuses are not used in circuits to save electrical energy. Ah, to prevent the current from becoming too large. Yes, this is correct. Information describes the currents in 3 different circuits. Circuit P has a steady current of 0.52 amperes in one direction. Circuit Q has a current that continually changes between 0.25 and 0.35, but is always in the same direction. Okay? Has a steady current of 0.52 amperes in one direction. The other circuit, which is circuit Q, it changes between 0.25 and 0.35, but it's always in the same one direction. Circuit R has a peak current of 0.52 that changes the direction periodically. Okay, it changes the direction periodically. Okay, What happens? Okay, which circuits contain a direct current? Which circuits contain a direct current? Whenever I say that the circuit has a current moving in one direction, in only one direction, this means that it is a DC, literally DC, direct current. Okay? Direct current means it's moving in only one direction. That's literally the meaning of DC, of direct current. Okay? Again, the circuit Q, it's moving in also one direction. So it's also DC. It's also a direct current. DC. Circuit R has a peak current, but it changes. Okay, the problem is that it changes the direction periodically. Okay, changes the direction means that this is an alternating current. Okay, alternating current, an AC current. So the only two DC currents are P and Q. P and Q. Okay, why? Because the current is moving in one direction. Literally, that's the meaning of direct current. Okay? Okay. Which transformer can change a 240 volt into a 15 volt output? 240 volt input into a 15 volt output. Hmm. How can I find, how can I choose? Hmm. Which of these transformers would be correct? Yeah. We only have one we only have one equation we use. Okay, we only have one equation we use. Actually, this is a bit more tricky. Why? Because all of these transformers are step-down transformers. All of these transformers are step-down transformers. So the equation we use is Vp over Vs equals Np over Ns. Okay, Vp is 240 divided by 15. It should be equal to one of these. Should be equal, is it equal to 800 over 40 or is it equal to 1000 over 25? Okay, you can try them out. The only right answer would be 1200 divided by 75. Okay, which would be D. It's just a matter of trial and error. Okay. Hmm. Question 37. Okay. The diagram shows a wire hanging from a metal loop P and dipping into a bath of mercury. This is an interesting question. Okay. Um, the wire is hanging vertically between the north and south pole of magnet. The loop P is then connected to a positive terminal of a battery, and the mercury is connected to a negative terminal. Okay, doesn't matter. This is a positive terminal, and this is connected to a negative terminal. So we have a current passing through this wire. We have a current passing through this wire. The current is now moving downwards. This is the current passing through the wire. The wire now swings out of the page, which is okay, good. The wire swings out of the page. What happens? Okay, what happens? In which direction does the wire move? Okay, when P is connected to the negative terminal of the battery and the mercury is connected to the positive terminal of the battery. In other terms, what happens if you switch the current? What happens if you reverse the current in the wire? Okay, if the wire is now moving out of the page, the wire is now moving out of the page, and you simply reverse the current, what happens? Yes, it will move into the page. That's it. That's it. Okay. All you did was that you reversed the current. When you reverse the current, what happens to the motion? It gets reversed. So if it was out of the page, it will go into the page. And that's it. Okay. That's it. Yeah. Hmm. We reversed the magnet. Who said? Who said so? Hmm. Did we reverse the magnet? Did he say that he reversed the magnet? He didn't say that the magnet was reversed. Okay, the magnet will be as is. Okay, the only thing that will be reversed is okay, the only thing that was reversed is the current in the wire. That's it. When you reverse the current in the wire, then the motion or the movement of the wire will be reversed. And that's it. Please read the question carefully. Please. The atoms of an element can exist in different isotopes. What's the difference between atoms of different isotopes of the same element? Isotopes of the same element. Huh. If we have isotopes of the same element, what do I mean by isotopes of the same element? They have different number of electrons, they have different number of protons, they have different number of protons only, they have different number of neutrons only. Definitely, it would be, it would be, يلا يا شباب. What's the answer? Can exist in different isotopes. If they exist in different isotope, huh, what's the difference between atoms of different isotopes of the same element? If they are the same element, they have different number of, yes, different number of neutrons only. Okay, the protons has to be the same. The number of protons has to be the same. Hmm. Yeah, a radioactive source has a half-life of 0.5 hours. Okay, detector reads 6,000 counts. Background radiation can be ignored. What's the reading after 1.5 hours? 1.5 hours. Again, for the millionth time, what should we do? The time divided by the half-life. Well, the time divided by the half-life is 3. This means 3 half-lives. I will divide by 2 3 times. You have to divide by 2 3 times. 6,000 divided by 2. 3,000. Divide by 2 again. 1,500. Divide by 2 again. 750 counts per second. Okay. Divide by time. Divide by the time, total time, divide by the half-life, which would give you 3 half-lives, divided by, so you have to divide 6,000 divided by 2 3 times. 750. Which statements which statement about explains why radioactive materials need to be handled carefully? Why should we handle the radioactive materials carefully? Hmm. Gamma rays are part of the electromagnetic spectrum. Radioactive decay is a random process. Have a half-life. Radiation is ionizing. Why are they dangerous? Why is it dangerous? That's definitely because they have because there's a fear of ionizing radiation. Yes, they could cause cancer or mutation. Okay.